Now let us understand functional group and homologous series. Functional group, remember, is an atom or group of atoms which when present in an organic compound changes the properties of the compound to such a great extent that the whole of the properties of the compounds are identified and are named, and that all of the compounds, everything, physical, chemical properties, everything becomes because of that group. So that is why that group becomes the main functional group, functional part of that particular compound, and that is why we call such an atom or group of atoms as a functional group. So these are the atoms or group of atoms which plays a very important or characteristic role in the properties of the compound. That, like let me give you an example. Like we have alcoholic group, which is being represented by OH group. We know like aldehyde group, CHO group, and carboxylic groups, COOH group. Now let us understand what exactly is the homologous series. See, each kind of organic compound having a specific functional group, those compounds, let me tell you again, those compounds which are basically having a specific type of a functional group, they together form a series in which the successive or the two compounds differ only by the difference of the CH2 group. It means what? When those organic compounds which are having specific functional group are arranged in the increasing order of the number of carbon atoms, what we find is the successive members differs only by the CH2 group. Such are called homologous series. Now let me give you an example, like in case of alkanes, whose general formula is CnH2n plus 2, the members CH4, C2H6, C3H8, C4H10, all of these, what we say, differ by CH2. Similarly, if we have alcohols have a formula CnH2n plus 2 and O. So what we find is, let me have the first example, like if we have 1, so it will be CH4O, the next one C2H6O, then C3H8O. So like this, what we find is, again, any two successive members differ from each other by a difference of CH2. Such are called homologous series. Now let us see the nomenclature of the organic compounds. See, the organic compounds are given basically the nomenclature system, which is actually has been designed by IUPAC, which is it's an abbreviated form of International Union of Pure and Applied Chemistry, which decides that how an organic compound is to be named, so that there is a complete uniformity throughout the world. Now this IUPAC gives us guidelines from time to time to how to name the organic compounds. So let us see the IUPAC nomenclature system. Now, as per the IUPAC nomenclature system, remember the first and the most important word in the nomenclature is your alk, which means actually the word root, the number of carbon atoms which are there in the organic compound. And we know that if the number of carbons are 1, we call it meth. We know if it is 2, we call it eth. If it is 3, then we call it prop, but, pent, hex, hept, oct, non, dec. Like so, this is how we name the number of carbon compounds which are there in the organic compound. After that, we put certain suffixes which basically not only indicates the type of hydrocarbon to which the organic compound belongs, but also the suffix are given to specific function, to every function group, so that the function groups which are present in the organic compound are indicated by those suffixes. Then we put certain prefixes before this. They indicates us the type of substitutional group which is present in the organic compound, as well as whether your organic compound is acyclic or alicyclic. So we put cyclo sort of prefixes. So this is how is a general basis of giving the IUPAC nomenclature. In this, the first alphabet of the nomenclature is always kept capital. We differentiate the position of the substitutions or functional group by writing their exact number to which the carbon number to which they belong. That's called locant. And we follow certain rules which will be explained to you with certain specific examples. Along with this IUPAC nomenclature, the most commonly used organic compounds are also given their common names, which are also called trivial names. So common names and trivial names basically are given on the basis of the sources from which we get those organic compounds. So they are not actually, there is no such rules to name them. They have been actually given by certain different languages in different languages and then adopted accordingly. So those compounds which are very common, which are very actually useful in day-to-day system, they are given trivial or common names. So now let us understand these by taking certain examples. Let us see the nomenclature of the straight chain alkanes. Straight chain alkanes. How they are named? Let us see this first. The straight chain alkanes, like we are having suppose CH3, CH2 and CH3, it will be called, there are 3 carbons, prop, all are single, so we call ane, because we know that this alkanes basically are having a formula CnH2n plus 2. These are called saturated hydrocarbons or paraffins because they are least reactive, they don't have any polar bonds. And they are named as alkanes. So alk is the number of carbon and ane is the indicator and the suffix which is given to indicate that they all are having saturated or single carbon-carbon bonds. Similarly, if you are having CH3, CH2, CH2, CH2 and CH3, we call it what? 3 to 5, we call it pentane. In common nomenclature, to name these compounds, we call it N-pentane. N is a prefix which is written before the alk in order to indicate that it's a straight chain hydrocarbon. Now let us see how we can name the branched alkanes. So how the branched alkanes are named. See, we have suppose this compound. In this, remember, we will always look for the longest chain, and on this longest chain there is of 3 carbon. Now this is the side chain or the substitution we are having, or the branch we are having branching from the main chain. Now this branching is called in general called alkyl, where alk is again the number of carbon atom. Now since the number of carbon atoms in the substitution is 1, it is called methyl. Now what is the position of this methyl group? It is 2. So this is how we write 2-methyl, and since the chain is of 3 carbons, we call it propane. Similarly, we can have the compound like suppose CH3, CH2, CH, CH3, CH2, CH2 and CH3. Now this compound, if we go, what we have to do, we have to search for the longest chain, 1, 2, 3, 4, 5, 6, 7. So it's of 7 carbon. Why, the question comes is why we are not starting the numbering of the carbon chain from here on, from the right hand side? Why only from the left hand side? The reason is here this longest chain is having 2 substitutions, both are methyl, but what are their positions are, which are called locants? It's these carbon number 2 and carbon number 4. Remember, we have to give these numbers the lowest possible number, and the sum of these numbers should also be the lowest. So from here, if we are going, we will get it 2 and 4, that makes it 6, and here the first substitution is on the second carbon. If we would have started the nomenclature from the right hand side, remember, then we would have got the first substitution at carbon number 4, which is actually not correct. So we will not follow this system. We'll number it from this side and we will call it 2,4-dimethyl heptane. And remember, so therefore what we do is we name these substitution groups, like if you are having this kind of a substitution group, we will call it ethyl. If we have this kind of a substitution group, we will call it iso. And if we have this kind of a substitution group, we call it what? Tert-butyl. This is called isopropyl. So this is tert-butyl, isopropyl, this is ethyl. So this is how we name these side chains, and this is how we name the branched alkanes. Now let us see some more examples of branched alkanes. Let us see if we have suppose this compound. Now in this, if we see, the longest chain of course appears to be the straight one, and it's having 3, 6, 8 carbons. If we start from the left hand side, our first locant or the substitution group or the branching is at the carbon number 3. And if we start from right hand side, it again is on carbon number 3. So, and if we are numbering it from here, it is at 3 and 6. From here also it is at 3 and 6. So let me show it to you. It's like almost like this. So it means what? That we are getting the locants or the number of the substitution groups same from both the sides, and the sum of these numbers from both the sides is also same. If this kind of situation appears, then always, and the groups are of the same type, then what we do is we follow alphabetical order. Else the preference order is to be followed. Like in this case, since they belong to the same type of group, they both all are alkyl, we will follow alphabetical order, and in which this is ethyl and this is methyl. So how we will name it? We will name it what? 3-ethyl. We will give preference to this one, and we'll write down 6-methyl, and it will be octane. And this is how it is to be named. We'll put ethyl before methyl because alphabetically E, and out of this E and M, E must come first followed by M. So it is 3-ethyl, 6-methyl octane. Now let us understand the nomenclature of complex side chains. If we have complex side chains, it means what? These are the chains which itself are having certain branches. Like suppose we have this kind of an arrangement. Now in this case, what we find is, like if suppose we are having this kind of an arrangement, like this one, let's take this molecule. Now in this, what we find is the lowest locant or the number of the substitution or branching is from left hand side is again is at carbon number 2, and from right hand side it is again at carbon number 2. But because since we have the third substitution at the 4th carbon from left hand side, definitely from left hand side the sum of these positions of the substitution or branches will be less. So we will follow, that's called sum rule. So we will follow the numbering from the left hand side, from here side, this side. Remember this will be longest chain from here also, it's the same thing. Now, what sort of branches we are having? This one, this whole, this one, and this one. These two we know that these are called methyl. Now the question comes is how to name this branch. This branch, because itself is having a side branching. If suppose this is not there in this, we could have easily called this as to be a propyl. But since it again is having a branching, how to name this? In this case, this type of side branches are called complex side chains. In this, what we do is we again number them by using 1 dash, 2 dash, and 3 dash. And then what we do is, like it is propyl, or the longest, this is a chain of a 3 carbon, so we'll call it propyl, and these two are methyl. So methyl will come first, so we will write down 2,7-dimethyl. Why di? Because there are 2 methyls. So in order to indicate the number, we put di, tri, tetra, etc. And then this whole bigger complex side chain is at carbon number 4. We'll put 4, then we'll put a bracket, and then we will write down this methyl's position. This is at 2 dash methyl. So this is at 2 dash, you have a methyl, and this whole chain is of 3 carbons, so it is called propyl, and this is how we name the complex side chain. And since this compound contains 8 carbon longest chain, so it is called octane. So this is how we name the complex side chain compounds. Now let us see the nomenclature of cyclic compounds. We're talking about alicyclic one. It's like this. This will be called cyclohexane. Similarly, this will be called cyclopentane. This will be called cyclobutane, and this will be called cyclopropane. If suppose you are having this kind of a situation, here we have an ethyl, here we have a methyl. In these alicyclic compounds, we can start the numbering from any carbon because all carbon are similar. Only thing is this, we have to follow the same rules that we have to give the lowest number to the side branch, and we have to follow that their sums must be the lowest. So we will start from here. If we start from here, we will get it 1 and 3, so the sum is 4. And even if we start from here, we'll get 1 and 3, and the sum will be 4. The only difference is that since the sum is from both the sides, we'll give what preference to the alphabetical order. And this E comes first, so we'll name it 1-ethyl 3-methyl cyclohexane. If suppose you are having, let me give you the example of another type. If suppose we are having example like this, in this case, this kind of a system is not followed because we have to start the numbering from this side, because then only it is, this is 1,1-dimethyl, because there are 2 methyls in this, 3-ethyl cyclohexane. Now in this case, the sum of these positions of the substitution of the side branches is 1, 1 and 3, which makes it 5. If we would have started the nomenclature like this, then it would have been 3,3-dimethyl 1-ethyl, and in that case the sum would have been 7, which is not followed, or no, which is not preferred. That is why this is how we name the cyclic compounds. Let us see the nomenclature of organic compounds having functional groups. Let me tell you exactly that what all other common non-functional groups we have, we find usually there in the organic compounds, and you must know their preference order also. The most important and the most preferred functional group is the carboxylic acid. That's given the highest priority or the preference. It is being followed by the sulfonic group called sulfonic acid. Then we have esters, COOR. Then we have acyl chlorides. These are called acyl chlorides. Then after this we have amides, and we know that these are the carboxylic acid derivatives because they are derived, they are obtained from carboxylic acids. Then the next in the priority list are your cyanides. Then after cyanides we have CHO called aldehyde group. Then we have ketone group, followed by hydroxyl group or alcoholic group, and then we have the amine group. In the end, it comes the double bond followed by triple bond. That means alkenes and alkynes. So these are the usual functional groups we find in the commonly available organic compounds, and this is their preference order is. And we know that you need to remember two basic rules while naming the organic compounds having functional groups. If the functional group is having carbon, that carbon must be given the lowest locant or the lowest number, or the chain must start from that carbon so that it already acquires the lowest number. Another important thing, that this rule is, we have to keep one thing in the mind, that ketonic group is always there in between the chain. So this must get a lowest number. Otherwise, in all the other functional groups like acid, esters, acyl, amide, cyanides, nitriles, aldehydes, in what we find in all these is that the chain must start from the carbon atoms of these functional groups. Another thing is most important, which we have to remember, is if the functional group is having two of these functional groups, the one with the higher priority is taken as a main functional group, and the one with the lower priority is taken as a substitution. So its name, the substitution groups, the functional group which is taken as a substitution, its name is indicated by a prefix in the IUPAC nomenclature. That is why every functional group is having a 1 suffix and a 1 prefix, so that if there are two or more than two function groups present in an organic compound, the highest priority one is regarded as a main functional group and whose name is indicated with the help of a suffix, and rest all the names are indicated with the help of those prefixes which have been assigned to them. Now let us see these function groups one by one, how they are named. Now let us see, I'm drawing a sort of a table. We'll put it like this: function group, its structure, what all suffix we assign to it, and prefix, and then we will discuss certain examples of it. Let us see, we have the first is carboxylic acid. We know it is C double bond O OH group. Let me put R here. So this is its structure. Now in the IUPAC nomenclature, they are called alkanoic acid. So oic acid is the suffix which is added to the alk and the primary suffix. So oic acid is the secondary suffix. This is, remember, these all suffixes will be secondary suffix, and these all prefixes will be your secondary prefixes. Now carboxylic group, since it is given the highest priority, doesn't usually is indicated by any prefix, but still it has been assigned a prefix called carboxy. We can have the examples like we have the first acid is HCOH, which is called methanoic acid. Now in the tribal nomenclature system and common nomenclature, which I will be taking it simultaneously, these acids are named by the word called, in this case it is used, we use form. Now this form is basically obtained from its source name. So form plus what we do is we put ic acid, that's why it's called formic acid. So what we say, we will use acid's common name, and then we will put ic acid in this, we will add a suffix, and this is how we give these acids or these organic compounds their common nomenclature system. Now let me give you another example. Like if we have 2-carbon acid, definitely in the IUPAC nomenclature it's called ethanoic acid, and in the common nomenclature we call it acetic acid. So ic acid is the suffix which we have added to the acid's common name acid. So 2 carbons, acid, and the derivatives will be given acid name, one will be given form name, and this is how we name it. If this group is there attached to the benzene ring, we will call it what? Benzoic acid, which used to be was its common name, but now it has been IUPAC accepted. Otherwise, it's another, which is the exact IUPAC name, is benzene carboxylic acid. The reason being, we cannot count this carbon in the chain of the 6 carbons of benzene, so this carbon is indicated by the name carboxylic acid. So this is how we name carboxylic acids. Let us see now the next functional group called sulfonic acid. It's written RS double bond O double bond OOH. In short, we call it RSO3H. This is sulfonic acid. The name given to these compounds is alkane sulfonic acid. So sulfonic acid is the suffix which is added to this. The prefix of this group is sulfo. That will be only used when this group as well as carboxylic group both are present on the carbon compound, and since this is having a low priority, it is indicated by the prefix called sulfo. That we will do later on in 1 or 2 examples. Now let us see the examples. Like first one, we have CH3SO3H. This will be called methane sulfonic acid, and in the common nomenclature we will call it what? Methyl sulfonic acid. If we have, suppose this is attached to benzene ring, we will call it what? We will call it benzene sulfonic acid. We also call it BSA. So this is how we name sulfonic acids. Now let us see the next function group called esters. Esters are having R, C, double bond, O, O, R dash. We need to know one thing which is very important in case of esters is this, that it's having two alkyl chain. The one which is indicated by R dash is basically is actually has been derived from the alcohol. We know that esters are obtained by the combination of an carboxylic acid and alcohols. So this R dash group is from alcohol, which is having an O attached to it. And the one which is attached to this carbonyl group is the one which is actually being was part of the carboxylic acid group. So how they are named? We first name this alcoholic part and then we write down the acid part. So we always write its name as alkyl alkanoate. So oate is the suffix and this alkyl indicates this alcoholic part. Now this alkanoate of course is the name of the acid which is there from which it has been obtained. Its prefix is alkoxycarbonyl. Alkoxycarbonyl. Let me give you an example now. If suppose we are having this ester, we can easily make out this is the alcoholic part. We will call this as methyl, and this acid is of 2 carbons, so we'll call it ethanoate. If we have to name this compound as per the trivial or common nomenclature system, we'll call it methyl because this alcohol is actually methyl, from where this ester has been obtained. But this acid in the common nomenclature is of 2 carbons, so it will be called SC. We will call it tate, acetate, because it's a derivative of acetic acid. Similarly, if suppose we have CH3, CH2, COO, H2CH3, this is the acid we are having. Now these 2 carbon chain is of alcoholic part, so we will call it ethyl, and the acid chain is of 3 carbons, so we will call it propanoate. And in the common nomenclature, we will call it ethyl propionate because 3 carbon acid is called propionic acid. Now, any one of these, the alcoholic or acid part can be aromatic also. Let me give you 1 or 2 examples of that again also so that it becomes very clear. Suppose we are having this kind of system. In this, it will be called what? Ethyl. This is alcoholic part, and this is called benzoate because this is the benzoic part. We can also have this kind of a system in which what we find is alcoholic as well as the acid part, both are aromatic, so we'll call it phenyl benzoate. So this is how we name esters. Now let us see the nomenclature of acyl chlorides. Their structure is RC double bond OCl. Their name is alkanoyl chloride. So we put oil chloride as the suffix. Their prefix is chlorocarbonyl if it is present as a substitution. Now let me give you the examples. Like if we have CH3COCl, it's called ethanoyl chloride. And in common nomenclature, since 2 carbon acid is acetic acid, this is called acetyl chloride. So we always delete O of the suffix and then we put it to the acid's common name, and this is how it becomes the compound's common name. If it is attached to the benzene ring like this, we call it benzoyl chloride. So this is how we name acyl chlorides. Now let us see Amides. Now, amides are RC double bond ONH2. They are named as alkanamides. So, amides are the is the suffix which is attached to the alkane, and this is how it becomes their IUPAC name. In prefix, they are called carbamoyl. That's the suffix prefix they had been assigned. Now let me take you the examples of amides. Like if we have suppose CH3 C double bond ONH2, we call it what? Ethanamide. I think this becomes very clear to you from this nomenclature system. Now in common nomenclature we will call it acetamide, because acid is the name of the two carbon acid from which they have been obtained. Similarly, we can write, if they are attached to the benzene ring, we call it benzamide. We also call it benzene carboxamide, because that's like how this is how we can name it. So it's also called benzene carboxamide. So this is how we name amides. Now let us see how we name cyanides. Cyanides, RC triple bond N. They are called alkane nitrile. So nitrile is the suffix which is attached assigned to them, and cyano is the prefix which is given to them. If suppose we are having this cyanide, we call it, since it's of 2 carbon, we have to count the cyanide's carbon. It is called ethane nitrile, or it is also called methyl, and we will call CN as cyanide in the common nomenclature system. Similarly, if the chain is of this compound is having 3 carbons, we will call it propane nitrile, or it's also called ethyl cyanide. So this is how we name cyanides. Now let us see now aldehydes. Aldehydes are RC double bond OH. They are always present at the end of the chain. They are called alkenyl. So Al is the suffix which is attached to them, and formyl is the prefix which is assigned to them. Now, if suppose we have the first aldehyde, it is called methanol, and in common nomenclature we know that since 1 carbon acid is formed, we put a word aldehyde to this, so it's called formaldehyde. Then if we have 2 carbon aldehyde, it is called ethanol. We call it acetaldehyde. And if we have this attached to the benzene ring, we call it benzaldehyde or benzene carbaldehyde. So carbaldehyde is another name which is attached to this, because you cannot count this carbon in the chain of the 6 carbons of the benzene ring. So this is how we name aldehydes. Now let us see the nomenclature of ketones. Ketones are RC double bond O R dash. They are called alkanon. So ON is the suffix which is attached to them, and the prefix assigned to them is oxo. They are sometimes they are also called keto also. So let us see the first ketone. Like it must have a 2 carbon around it, so that becomes of 3 carbons. So we call it propanon. In common nomenclature, we name these 2 chains and we call this CO as ketone. So we call it dimethyl ketone. And it's also called acetone commercially. If we have, suppose this is attached to a benzene ring like this ketone, we will name it 1, 2. So chain becomes of 2 carbons. So we will call it phenylethanone, and its commercial name is acetophenone. If suppose we have two benzene rings attached to a keto group, it's called diphenyl methanone, or it's also called benzophenone. That's its common name. Then let's see how we name alcohols. R, OH are called alcohols. Their IUPAC name is alkanol. So OL is the IUPAC name, and suffix OL is the suffix which is attached, and hydroxy is the prefix which is assigned to them. The first alcohol is of one carbon. It's called methanol, called methyl alcohol in common nomenclature. This is methyl, this is alcohol. In a very similar way, if it is what CH3, CH2OH, we call it ethanol or ethyl alcohol. If it is attached to a cyclic ring, carbocyclic ring, so like this, OH, it is called cyclohexanol. Common name will be cyclohexyl alcohol. And if it is attached to a benzene ring, it's called phenol in the common nomenclature, which becomes IUPAC accepted, else it's called benzenol. So this is how we name alcohols. Now let us see how we name amines. Amines are RNH2 groups. We call them alkane amine, and amino is the suffix assigned to them. So amine, A-M-I-N-E is the suffix which is given to them, assigned to them, and this is how this becomes their IUPAC nomenclature, whereas amino is the prefix. Like if we have CH3NH2, we will call it what? Methanamine, or common name is methylamine. CH3, CH2, NH2, we call it what? Ethanamine, or it's also called ethylamine. If it is attached to benzene ring, it's called benzenamine. It's also called aniline. Common nomenclature, which is again is now IUPAC accepted. The amines can be, this type of amines are called primary, and if this N is having one more carbon chain, it's called secondary, and if the N is having 3 carbon chains, all hydrogens substituted, it's called what? Tertiary amine. Now like if we have suppose CH3, CH2, this N, NH, and this CH3, this is an example of a 2-degree secondary amine. Now in this, always remember the N goes with a bigger chain. Smaller chain becomes a substitution, so we will call it N-methyl ethanamine. Ethanamine. So this is how we name amines. And we know how to name the alkenes and the alkynes. So this is how we name the organic compounds which are having function groups. Now let us see the nomenclature of the substituted benzene compounds. First, you need to understand this, that if a benzene is having one group attached to it, if it can be a substitution or a function group, that is a material. But if benzene is having one group attached to it, which is given in this as G, remember the other positions are given certain prefixes to indicate their exact position. Like if I number these, all the 6 carbons, 1, 2, 3, 4, and we have a main group attached to the first carbon, then remember, then the position number 2 and 6 are called ortho, and we give a symbol O. The position number 3 and 5 are called meta, and we call it M. And the position number 4 is called para, and we call it P. And remember, these all are the symbols ortho, meta, para used in the common nomenclature system. Otherwise, in IUPAC, we will always indicate the position of the second substitutions by the carbon number to which they are attached. Let me give you the examples. Like suppose we are having here, we have nitro, methyl, and chlorine. So in this case, we will start definitely, we will follow the lowest locant rule, lowest sum rule. We have to follow these rules. So we will follow what? This order, because by this, the sum will be the lowest of the positions of the substitution groups or the functional groups. So what we find in this case is that this name will be different. This is chloro, this is methyl, this is nitro. So we'll call it 4-chloro, 2-methyl, 1-nitrobenzene. If suppose we are having a compound like this one, in this case, out of these three groups, definitely what happens is the OH is the one which is getting the highest preference. That's a function group. So we'll start our nomenclature from here only, and we will number them like this. So we'll call it what? 3-methyl, 4-nitro. We'll call it 4-nitrophenol.